Hey, in this video I'm going to talk about the copy assignment operator, and we'll also overload this as a member function. Here are some of the redefinable compound assignment operators, and of course we also have the assignment operator. We also have multiplication and assignment, subtraction and assignment, and addition and assignment, and so on. Before we continue, I'd like to look at a few examples in Visual Studio, so mainly why we need to overload the copy assignment operator, and then also a few notes and observations on the assignment operator. Okay, I'm in Visual Studio and I have the entity class here again as an example. Continuing on from the previous example, we have the constructor right here and the copy constructor. The copy constructor delegates to the default constructor, and this again does deep copying. We have the destructor right here and then getMember as well, and so on. Again, we have this toString right here as well. In main I have a few integers x, y, and z, and then I have this statement right here. This is a training of the assignment operator. Okay, and then I simply print x, y, and z out. Okay, so that's an observation on the assignment operator with primitive types, is that we can train it. Okay, and then down here I have entity 1, entity 2. These will use the default constructor. And then here I declare entity 3 and initialize entity 3 to entity 1. So of course that's going to use the copy constructor now. And then I simply do toString entity 3, which will print out so entity p.getMember pointer again. I'll just build and run this so we can look at the output. The first line will print out 3, 3, and 3, and then the next line will print out 5. The second line prints out 5 because we have entity 3. We initialize that to entity 1. And with entity 1, we can see we pass in an argument of 5. So this works fine, but there's a bit of a difference again between constructing an object, using constructor, so the default constructor or the copy constructor, and using assignment. So let's say following this toString function call, we would like to reassign entity 3 maybe to entity 2. Okay, so here I do entity 3. This is not a declaration of a new entity. It already exists, right? So this is going to be an assignment. But if I scroll up as a reminder, you'll notice that we do not have an overloaded assignment operator yet. Okay, so if you do not have a user-defined copy assignment operator, then the compiler is going to provide one, and that's going to do simple member-wise copying. And if you think for a second, some of the problems that we had in the previous video, where the address was simply copied, alright, so the member pointers of both of those objects pointed to the same heap memory. And of course, when you invoke the destructor on either one of those, you can end up with a dangling pointer. And actually I'll just build and run here for a second and you'll see we get this crash and this error again. I'll just abort. And we're gonna learn how to fix that and do a deep copy assignment operator in this video. Okay, I'm gonna use this illustration to try and explain to you why we get the crash. And it actually does not have anything to do with the toString function call. Remember that we fixed that problem with the copy constructor by doing a deep copy. At the top you can see an example of the shallow copy assignment operator, and this is basically the same thing that you're gonna get with the compiler generated default assignment operator. Okay, it's simply going to be a shallow copy assignment operator, because as you can see in this example, what it's going to do is it's going to copy the address. So other.member pointer, it's going to assign that address to the member pointer of the calling entity or the calling object. So we are fetching the address in this example from entity 2, and we are copying that into the member pointer of entity 3, okay, in that assignment statement. And similar to the problem that we had in the copy constructor, they are now both pointing to the same dynamic variable which is on the heap. So where does the problem come in? Well, the problem comes in when the program terminates, so in the main function, when we reach the closing curly bracket, the variables that are local to the main function will get destroyed. Okay, so let's say we go through and we destroy entity 3. This is just an example, so either one of these could be destroyed before the other one, right? So we are not really concerned with the order of which one of these are destroyed first. But just as an example, let's assume that entity 3 gets destroyed first. The destructor for entity 3 is called, and that is going to deallocate the dynamic variable pointed to by its member pointer. And what does that mean? Well, the member pointer of entity 2 is now dangling. Okay, entity 3 is destroyed, now we're going to destroy the next object, which is entity 2. But again, the member pointer for entity 2 is dangling. As we've seen previously, that is a problem. We are going to get an error or undefined behavior. Okay, just a summary on some of these observations that we've seen. When we use the assignment operator, we assign the right-hand operand to the left-hand operand, of course, and then also assignments can be chained. So we can do X, the assignment operator, Y, the assignment operator, and Z. Now what does this mean? Well, the assignment operator has right to left associativity. This means Z is assigned to Y, and then that is assigned to X. Another important note here is the difference between construction and assignment. In the first statement, entity 1 and entity 2, it's fairly obvious that those are constructions, so we are constructing or instantiating new objects. In the second statement, it's maybe less obvious because we use the assignment operator, but actually we'll also use a constructor, in this case the copy constructor. And as I mentioned in the previous video, if this is confusing to you, use the construction syntax instead and then pass in the entity that you want to initialize that object to, right? You can see here with entity 4, for example, I use the constructor syntax. Entity 4 I have parentheses and I pass in entity 1. Whereas the final statement, so the fourth statement, that is of course assignment. Entity 4 already exists and we are now assigning it to another entity, to entity 2 for example. As I mentioned, if no user-defined assignment operator is provided, then the compiler generates a default one that are shallow copying. This is fine if the user-defined type does not contain pointer members. So again, we're going to have the same problems that we had in the previous video with the shallow copy constructor. So when do you need to overload the copy assignment operator? Well, if the class or struct has pointer members, then you want to do a deep copy, right? Here is the copy assignment operator declaration and definition. You can see the prototype or the declaration that is going to return a reference to an entity. And you see we have the operator keyword again and the assignment operator. The formal parameter is also a reference to an entity constant. And also have the definition down here just so you can see what the header will look like. Where you need to use the scope resolution operator because that can also be a bit confusing when you do this for the first time because this line gets a bit busy, right, with all of these operators and things going on. Now as we go through the rest of the video, we'll look at what the definition should be. So in other words, what you actually want to put in the body of the copy assignment operator when you overload it. Okay, before we move on, let's take a step back and we'll look at an example where we do not have a pointer member. Okay, I'll use the vector2d again in this example, the vector2d struct. Here I overload the assignment operator. The formal parameter again is a reference to a vector constant. It is named other. So all we are going to do here is member-wise assignment. Member-wise assignment is going to do assignment from each member of other, or the object that we pass in as an argument, to the corresponding member of the calling object. So we do x is equal to other.x, y is equal to other.y, and then here we return this, we do reference this, and we return the calling object. Basically we are going to return a reference. Otherwise we return a copy, and in that case you invoke the copy constructor as we've seen in the lecture on copy constructors. So instead we return a reference, and that will allow for chaining. Okay, so let's just go back to main. I instantiate vector2d. I have vector1, vector2, and vector3. Okay, vector2 is initialized. Here I use list initialization. I don't actually have constructors for the vector2d in this example, so I'm simply using list initialization. Vector1 will be 0, 0 initially. Vector2 will be 3, 5 initially, and vector3 will be 12 and 12. First, it's going to print out what vector1 is. It should print out 0 and 0 for x and y. Then I assign vector2 to vector1, alright, and that should print out then 3 and 5 for x and y. Here I do the chained assignment and it should print out for each one of these now. For vector1 and 2, it should print out 12 and 12. And that's what we get. We get 0 and 0 printed out initially, then 3 and 5, and then 12 and 12. Twice here following the chained assignment. A few things to remember, this is infix notation. The function is going to get invoked on the left-hand operand, and it's going to take in as an argument the operator that is on the right-hand side. So this is similar to writing. Okay, so these two lines are the same thing. This is simply a call to the function, whereas this here uses infix notation. I'll just build and run and you'll see we get the same output. Okay, one final thing I'd like to note is that if I remove this, actually, I'll just comment that out. it is now going to use the compiler generated assignment operator, and that's also going to do member-wise assignment, just like we've done right here. If I build and run, as you can see, we get the same results. So as you can see, overloading the assignment operator is more useful when you have pointer members, because here we simply could have used the default one that was provided or generated by the compiler. Okay, so in this chained assignment, it's going to evaluate this first here. The associativity is from right to left. The function is called on vector2, and then we pass in vector3 as an argument. The members of vector2 will now both be 12, so 12 for x and y. And then similar to what we've done here, I'll actually just uncomment that. It's going to return a reference to the calling object. So once we are done executing this, it's going to return a reference to vector2, and then we are going to assign that to vector1. Now remember, we've changed vector2. The members are now 12 and 12 for x and y. Again, we do member-wise assignment to vector1 now, and that's why vector1 will also now have 12 and 12 for its members, x and y respectively. Okay, and that's where we get 12 and 12 printed out twice when we do this here for vector1.x.y and vector2.x and .y. Okay, this was a look at overloading the binary assignment operator as a member function. In the next example, we'll talk about some of the complexities involved when we have member pointers, where we overload the assignment operator when we have pointer members. Okay, I'm gonna use the entity class again that we've used for the copy constructor and in the previous example in this video as well. We have the default constructor and the copy constructor being set up properly as discussed in the lecture on the copy constructor. We have the destructor again that's going to delete member pointer or deallocate what it points to. But the point here is, again, we have a pointer now, a pointer member. Okay, I'll scroll up to maybe over here. Okay, so in the previous section where I talked about the vector, we've seen that this is basically what the default compiler provided assignment operator is going to do, and where we have a pointer, it's simply going to copy the address. As we've seen previously, that's going to cause errors and crashes in our programs. And to demonstrate how we can fix this problem, I'm going to move on to some slides again, some illustrations, and then we'll come back and implement that here in Visual Studio. Okay, in the case where we do have a pointer data member, we don't just want to copy the address over or do shallow copying. So what can we do? Well, it depends on the program, and I'm going to start off with a simple example. This is a simple example of a copy assignment, and for this example we are using a pointer to a primitive type, just an integer. Now it won't always be that simple. Sometimes you'll have pointers to objects or an array of integers, for example, and sometimes the array that's on the heap is larger than the one that the member pointer is currently pointing at. So in that case, you want to deallocate it first, and then you want to create a new dynamic array on the heap and copy things over. Otherwise you can lose a few elements, right? So it really depends on what you are doing, but in this case, it is pretty much as simple as it's going to get. Okay, so when program execution reaches this assignment statement, where we assign entity 2 to entity 3, what we want to do is we simply want to copy the value that is stored in the dynamic variable on the heap, which entity 2's member pointer is pointing at. Right, we want to copy that to the dynamic variable that the member pointer of entity 3 is pointing at. And that's exactly what we are doing in this copy assignment operator. Firstly, we do a check if this, which will fetch the current object's address, is not the same as, and we fetch the other object's address. We don't want to do unnecessary computation, right? So first we do a check to avoid self-assignment. Then we do other.memberPointer, and we dereference that to fetch the value. And then we assign that to the dereference member pointer of the calling object. Alright, and that way we simply copy the value over from one dynamic variable on the heap to the other. Okay, back in Visual Studio, let's go and fix our copy assignment operator now. It is right over here. I'm just gonna remove this line actually and do if. And here this is a pointer. This right here is a reference, so we want to get the address. Otherwise we are going to get an error. We do this check again to avoid self-assignment. And that is it. This is how we copy the value that is stored in the dynamic variable pointed to by this member pointer. Okay, the member pointer of other, or in other words the argument that we pass in. since this is a reference to that, and we store that value in the dynamic variable that this member pointer points at. Okay, remember again that we have this getter, and then again we simply have this toString function which is going to help us to print those values out. So firstly I construct entity3, I initialize that to entity1, that's going to use the copy constructor, then I print that out, so this should print out 5. Then here I do assignment, so I assign entity2 to entity3, that should print out 7. And then here I do assignment again, so I assign entity1 to entity3, and that again should print out 5. I'll build and run this, and that's what we get, 5, 7, and 5. And the program doesn't crash or anything like that. Okay, I'll change things around a bit. So I have entity1 set to 5, entity2 I pass in an argument of 7, entity3 I'll now use the default construct instead, and I'm gonna pass in 55. Let's see if this works. So I'm gonna do chain assignment. This should assign entity3 to entity2, and that modified entity2 will now be assigned to entity1. So all of these should print out 55 now. Pull and run, and let's see if that is what we get, and that is what we get. And we don't get any crashes, alright? Okay, this was again a very simple example using a pointer to a fundamental type. Now what if we have something more complex? So let's say the object on the heap is actually an array, not just an integer. Well, then things become a bit more complex, okay, and that is what we are going to cover in the next and in the final subsection for this video here. Okay, next we'll look at another example of the copy assignment. But in this example, instead of simply copying the value from one dynamic variable to the next, what we're going to do instead is we are going to deallocate the dynamic variable on the heap that the calling object's member pointer is pointing at. Then we're going to create a new dynamic variable on the heap, and then we copy values over or whatever it is that we want to do following that. In this example, we are concerned primarily with what's going on in the overloaded assignment operator. That is when we execute this assignment statement where we assign entity2 to entity3. From our previous discussions, it's clear that entity3 is going to be the calling object. So the stack frame which is on the stack here represents what's going on in that overloaded assignment operator. Then you can see we have the member pointer of this, or the calling object, in other words, entity3. That member pointer is pointing to some dynamic variable on the heap. Sometimes the object on the heap is not just a simple integer or a float, but to keep this example simple, we are going to use the same entity class that we've used in the previous example, and we simply have an integer here on the heap. But that could also be an array, right? A pointer to an array on the heap. So again, just keeping it simple, but the main difference is going to come in where we overload the assignment operator. Firstly, we want to avoid self-assignment, so we do if this is not the same as the other object. Then we deallocate whatever member pointer is pointing at on the heap. Then we go and allocate a new dynamic variable on the heap, and it will store the address of that dynamic variable in the member pointer now. And then we can do whatever copying it is that we want to do. Now again, for this simple example, we are simply copying the value, an integer value, from one dynamic variable to another. But as we'll see here shortly, it can get a bit more complex where you maybe want to copy over elements from one array to the next, and so on. So it really depends on the class and the user-defined type. Okay, here I want to illustrate to you what you should avoid, so what you do not want to do. And this relates to what can cause a memory leak. That is when you use this technique of creating new dynamic variables on the heap in the overloaded assignment operator. Now again, we are focused here on what is going on in the assignment operator. When we execute some of these assignment statements, you will not say entity2 and entity1 on the stack. We are focused primarily on the calling object, which in this case again is entity3, and what its member pointer is going to point at. Okay, so let's start off in the second statement in the main function. We construct entity3 and we initialize that to entity1. Then we move to the third statement in the main function where we assign entity2 to entity3. And that is where we invoke the overloaded assignment operator. And in the stack and heap illustration to the right, we can see the state of that object. Again, entity3 is going to be the calling object, so its member pointer is going to point to some dynamic variable on the heap, and the value that is stored in that is going to be 5. Okay, and that's basically because entity3 was created as a copy of entity1. Again, we are assuming that we have a proper deep copy constructor, as implemented in previous examples. Alright, so this is now the state of entity 3. Now in the body where we overload the assignment operator, you can see we do member pointer, the assignment operator, and then new int. That is going to allocate a new dynamic variable on the heap, and is going to assign the address of that dynamic variable to member pointer now. And then we simply copy the value over. But you can see where the problem comes in here, and that is we do not deallocate the object on the heap. That is before we create a new dynamic variable on the heap, and we do not have any way to access that dynamic variable on the heap anymore, so that produces a memory leak. Where we assign entity 1 to entity 3, the exact same thing is going to happen. We'll create a new dynamic variable on the heap. The statement will also assign the address of the new dynamic variable to member pointer, and once again we have a memory leak. Okay, so this is what you do not want to do. You want to firstly do a check to avoid self-assignment, then you want to deallocate the dynamic variable on the heap, then you want to create a new one, and then you want to copy your stuff over. For the final example in this lecture, I have a new class here called ArrayList, and I'll just scroll down here. In the private section you can see that we have two members. I have a list, which is a pointer to a char, okay, a character. I also have an integer called length. Okay, this will act as the default constructor here. I have a formal parameter here, length p, okay, that's an integer, and that has a default argument of 1. And this allows us to pass in how many elements we want this array to have. That is when we create a new instance of this ArrayList class. Okay, the first thing I do is I set the length member to that length p that I pass in the length parameter. This will determine how many elements are in the dynamic array which will be on the heap, right? So here I create a dynamic array on the heap, an array of chars, and I pass in length here. And this to say, okay, go and create a new dynamic array on the heap, and it needs to have this many elements. Okay, so just so that we have something to print out and that we don't have to do a bunch of getter functions and so on, I want to keep this simple. So all I'm gonna do is I have this for loop here, and I'm gonna assign this x character to every element in that dynamic array. Okay, so that's it for the constructor. Then we have the destructor, and of course that's going to do delete. We have the subscript operator and then list. Next I have the overloaded assignment operator. Okay, so you should be familiar with this header by now. It's going to return a reference to an array list. Again, we are going to return this. And then the formal parameter here is a reference to an array list constant. I do this check again to make sure that we are not assigning to ourselves. Then I'm going to delete whatever the member pointer of the calling object is pointing at. On the heap, right, we don't care about that. We want to get rid of it completely. So we are going to deallocate that because the object that we pass in as an argument, so the object that we are assigning to ourselves or to this, may have a list with more elements than the one that we are pointing at currently. And so because of that, we simply deallocate whatever we are currently pointing at. Once the assignment is complete, we want the amount of elements in the dynamic arrays to match. So in the object that we are assigning to ourselves, go and fetch the length and then assign it to the length that we need to be, basically. And then here is where we create a new dynamic array on the heap. Okay, so we've deallocated whatever it was that we were pointing at previously, and now we are creating a new dynamic array on the heap. And it has this many elements now, okay, our new length, and it's going to assign that address now to list. Then I'm going to do the same thing that I did in the constructor. I'm simply going to assign the character x to each element in that dynamic array. Down here again, I'm simply returning this. I also have this toString function. All we do is this for loop, and it's simply going to do console output list, and I pass in I. And that's why we do for as long as I is less than length. If we construct this entity to have 5 elements, for example, the array is going to start at 0 and go to 4. Now, of course, there are other checks that you can do. So in the constructor, for example, right here, you can do a check to say, okay, what is the maximum amount of elements that we want to allow this array to have? Let's say 50 or 100. And if we pass in an argument that is larger than that, then it simply uses that max value. Let's say again that is 50 or 100. But again, just to keep it concise, I also do not have for this example a copy constructor. But if you want for an exercise, you can go and try and implement that here. Okay, so that is a look at the toString, and I talked about the private section already. Finally, in main, I instantiate this ArrayList class. Okay, I construct ArrayList1. I pass in the argument 2, ArrayList2, and I pass in the argument 5. Then here I do ArrayList1.toString, and that should print out 2 x's for us. Then I do the assignment, so I assign ArrayList2 to ArrayList1, and I do ArrayList1.toString again, and that should print out 5 x's. I'll just build and run, and you'll see we get 2 x's and then 5 x's. And just for fun, let's do another one here. Alright, and that is going to use the default value of 1. And we are doing the chained assignment right here. Build and run, and that works as we would expect. Actually, I'm just going to change these two around. Okay, so ArrayList2 and ArrayList1 should now have dynamic arrays with 1 element. I'll just scroll up. You will see again that this is the default argument. And I simply do ArrayList1 and ArrayList2.toString here. Build and run, and that works fine. Prints out x twice and then once each time. So this means that we are successfully deallocating that dynamic array on the heap each time we do an assignment. So again, I'll scroll up. We are deallocating that dynamic array. We make sure that the number of elements are going to match. You can rename this maybe to number of elements. I chose length, that's just because I'm familiar with arrays, implementing arrays as lists. We create the new dynamic array, and then we store the characters in that. Okay, so this was a basic example. I tried to keep it simple for you, mainly because this module does not focus really on lists. You can do much more with this. You can do array-based lists where you can insert maybe in the middle somewhere or at the end or at a specific place in the list. And then of course you have to reorganize your stuff and move it around. You can do searching, you can do sorting and all of that stuff, but that's not a module 102 topic. That is really a topic for data structures. So maybe in module 201 as opposed to module 101 or 102, right? That is most likely a module 201 topic along with binary trees and so on. But that being said, I hope this gives you a good introduction and a good idea of how to go about overloading the assignment operator.